4.3549 milliamps. That's current through R3. Okay, so that gives us all our currents, right?
Yeah.
Okay, now it also says that R1 is 600 ohms. So if R is 600, VR1 would be 600 times 4.6451 milliamps. So VR1 is 2.787 volts.
Mhm.
Okay, it also said that our RT is 2K. Okay, RT is 2K. So now how do we find everything else? Well, we know if RT is 2K and IT is 9 milliamps, VT would be 9 milliamps times 2K, right?
Yeah.
Okay, so that's 2,000 or 18 volts. Okay, so what can we go with next? How can we figure the rest of this out? Okay, if we know R1, we know RT. Oh, okay.
Can you slide the paper up a little bit?
Oh, sorry. Okay, here we go. Okay, so right here, we know that the voltage across R3 is 6.9678, right? We also know the voltage across R1 is 2.787. So the voltage across R2 would be 6.9678 minus the voltage drop across R1 of 2.787.
Mhm.
So 6.9678 2.787 minus. So VR2 equals 4.1808 volts. Okay, so we know that if our source voltage, we found out VT? Yeah, VT is 18 volts. And R3 is 6.9678 volts. Then R4 has to be the rest, right? Go in the loop. So VR4 equals 18 volts minus 6.9678 volts. Equals 11.0322 volts. Its voltage across R4. Okay? So if the voltage across R4 is 11.0322 volts, and the current through R4 is 9 milliamps, what is the value of R4? It would be the 11 volts divided by the 9 milliamps. It's like 1.225K. So what haven't we figured out yet? We got the current through R2. Do we have the voltage across R2? No, we don't have that yet. Do we have the voltage across? Oh yeah, we do. We do have the voltage.
Voltage across R2.
Okay, we have the voltage across R2 and the current through R2, so we can figure out the resistance of R2.
Resistance of R2, yeah.
Yep, which would be 4.1808 volts divided by 4.6451 milliamps. I should have made a little graph easy to keep track of stuff. 4.108.
I know, it's hard to see anything.
Yeah, I'll do that next time. So R2 is basically 901.6 ohms. Is anybody checking the answer key to see if these are right? Let me see here. 9 milliamps. Where did I get? Yeah, that's cool. Close enough. So we figured out everything for R1. How about R2? R2, we know the voltage drop, and we also know the current through R2. We wish did that one. I'm confused now. Okay, next problem. Next time I'm going to keep a grid so I can keep track of stuff, and I know when I'm done. Let's do number 6, which is basically the same problem, only with different values. This time I'm going to keep a different, I'm going to make neater stuff here. All right. You just redraw the circuit. Okay. R1, R2, R3, R4.
There you go. That's gonna be nice and neat now.
Yeah. Okay, do number 6. IT is 1 amp.
Darren said, can you slow down on this one, Will?
Okay, I can do that.
And then if you can slide the paper over to the left a little, because we can't see R4.
Okay, how's that?
Let's see, wait for it. It's got a delay on it. And yeah, that's perfect right there.
Okay. Okay, looks like that's what we start with, right? So, first thing I would figure out is I would work on these totals here. We know power, we know current. So we know power equals voltage times current, right? So if you got 5,000 watts or 5K watts divided by 1 amp, you're going to get 5 kV, right? 5,000 volts?
Yeah, 5,000. Mm-hmm.
Okay, we also know that our resistance is our voltage divided by current. So 5,000 volts divided by 1 amp, that's going to give us 5K ohms. Yep. Look at my answer sheet here. Okay, so now, next thing I would do is we got to figure out some other stuff. Since R3 they give us the voltage and the power, we can figure out a current, right? It'll be power divided by voltage. So that'll be 732.37 in its watts divided by 1.9136 thousand volts, kilovolts. That gives,
382.718.
yep, 382.718, and that is milliamps, right? So now we can figure out the resistance of R3, which will be, well, we can do it a couple different ways. Since we already got the current, well, what I would do is I would divide the 1.913.
Voltage over current.
Yep. I got 5K.
Yeah.
Okay. Can that be right? Sure. Because I told her it's 5, but no, that can't be right.
Wait a minute here.
Yeah, let me look at my numbers. Yeah, that can't be right. This number. Yeah, that's what. Oh, yeah. I do got 5 on there. Something.
I got 5 also.
I must have miscalculated on this problem. Because it can't be. Cause
yeah,
I told
when you divide those, I come up with 5.
Yeah. Tell you what, let me check something really quick here. I must have got a number out of whack somewhere. So what do we got? R1, 2 would be 500. R3 is 5K. Yeah, 5K. Okay, so R3 is 5K, and the total is 5K, and we're still good. Yep.
So
Okay.
the rest of it has to be.
Because R3, since he's in parallel, is going to be less than 5K. 5K. We'll see. So now, let's see. What can we figure out next? We know. What do we know? We know that the current through R1 and the current through R2 are going to be identical, right? We also know that the current that goes through R3, if you subtract it from the total current, it will tell us how much current is going through R1 and R2, right? So our total current is 1 amp, and if 382 milliamps going to R3, how much is going through R1 and R2?
$617.282 million.
Yep.
Oh, yeah.
You're right. Okay, everybody see that? And we also know that R4, the current through R4 is what? 1 amp, right? Because he sees both of these put back together, which is the same as the total current. Okay, I'm having another bite of chicken. And okay, Frank, which one you want to solve for next?
Well, we could do either. We could R1, R2, or R4. We could do the voltage. We could do the resistance. Let's just do voltage for R1.
Okay. Now voltage for R1 equals we know that voltage
power divided by current.
Yep. So power is 190 divided by 617.282 milliamps. Oops,
308. Okay.
put it in the wrong place. It's up here. 308.64. Right? Okay?
Yeah, right there.
So now we can figure out the resistance of R1. We take the 308.64 divided by the 617 milliamps. It should give us our resistance.
Yeah, 500.
Okay? Let me just go to the voltage across R.
R2 and R4.
Okay.